So consider the data points. They given you 4 data points, x1, x2, x3, x4. 4 data points. Of these data points, x1, x2, x3 belongs to positive class. So this belongs to class 1, class 1, class 1. This belongs to class 0. The perceptron uses the following decision rule. So y hat is the predicted output equals to 1 when w transpose x greater than or equal to 0 and y hat equal to predicted output is 0, that is class 0, w transpose x is less than 0. So there, first we draw the points. Okay, so there are 4 points given, x1, x2, x3, x4. So this one, 1, minus 1, minus 1. This is one data point, x4. 1, minus 1, minus 1, minus 1. Minus 1 plus 1. 1, 1, x1. 1 minus 1, 1 minus 1, x2 and x3. That the decision boundary passes through the origin passing through origin and the point D. The weight vector is initialized to given the weight vector equals to W0 and W1 matrices. So W0, W1 and given W0 equal to minus 1, that is W equal to weight vector minus 1 comma W1. What is the value of W1? They are asking find the W1. So suppose that the decision boundary passes through the origin and to the point. The decision boundary always very important, always perpendicular to the weight vector. So W bar, weight vector. So always remember this point, very important. The decision boundary is always perpendicular to the weight vector. If it is weight vector like this, for example, the decision boundary is like this, always perpendicular to weight vector. And in this question they given that passing through the point D. So we know the weight vector and one point D equal to 0.5 and 1. So we know the decision boundary equation. We know that the decision boundary equation, that is decision boundary is decision boundary dby, decision boundary is perpendicular to weight vector W bar, that is decision perpendicular means dot product is equals to 0. Dot product is 0 because they are perpendicular. Perpendicular means dot product is 0. So that is, so weight vector W dot D bar equals to 0. Dot product between this point and the weight vector is 0. So W equal to minus 1 and W1 and D equals to 0.5 and 1 equal to 0. So you can multiply the dot product, minus 1 into 0.5 plus W1 equals to 0. So W1 equals to 0.5. They are asking in the question find the value of W1 that equals to 0.5. So weight vector value equals to finally minus 1 and 0.5. For this question answer is 0.5. Okay, correct. The points are correctly classified. Okay, how many points are correctly classified? This is perceptron algorithm. This is perceptron algorithm. For a perceptron algorithm, originally the given data point is negatively classified and originally positively classified. originally positively classified, and we find the W transpose X, W plus X, W minus X. Please remember N is negative, so minus X, P is positive, plus X. You have to remember this one is important to solve the question. So 1 comma 1, x2, x3 and x4, x2 equal to 1 minus 1, minus 1 comma 1, minus 1 comma minus 1. It is originally given negative, negative, positive, positive, positive. Given in the question. It's mentioned in the question. It is originally. Originally it is given. Find W transpose X. W transpose X. So we already find weight vector. So weight vector equals to minus 1.5, minus 1 and 0.5. Originally it is classified as positive, 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 and it is negative. So we find W. Okay. So we find here W1 W transpose X1. W transpose with the data point X1. So W1 equal to minus 1.5, 1 comma 1. That equals to minus 1 plus 0.5 into 1, that equals to 0.5 minus 1, that equal to minus 0.5. So originally it is positive, but we find the W transpose X. W transpose X, it was negative. Negative. Originally it was positive. We classified as W transpose X, it is negative. Negative. For this W transpose X is greater than 0. This one is positive. So if it is originally the data point X1 is positive, and if we find the W transpose X which is less than 0, so we add, that is misclassified. So this one is misclassified. For this W equals to W plus X. So use this one, W plus X1. So W equals to minus 1.5 plus X1 equals to 1 comma 1. So this one minus 1 plus 1 adds 0, 1.5. So again we find W1, this one is new W. W1 transpose X1, that equals to 0, 1.5, X1 1 comma 1, that equals to 1.5. Originally it classified as positive, and we get positive. Plus 1.5 is greater than 0, right? That is W transpose X equal to 1.5, that is greater than or equal to 0. It is class 1. For the perceptron rule, this given W transpose X greater than or equal to 0, it is classified as 1, that is Y hat equal to 1. So classified as misclassified, this one misclassified, and Y hat equal to 1. So for this we updated the weight vector. Here we updated the weight vector W1 0 comma 1.5. Next we classify the second data point, that is W1 transpose X2, that equals to 0, 1.5 with X2. X2 equal to 1 minus 1. X2 equal to 1 minus 1. X2 equal to 1 minus 1. So we find the transpose 0 minus 1.5, that is W transpose X is less than 0. In perceptron, Y hat equal to 0, negatively classified. But given X2 is, so X1, X2, X3 is classified as positive. Originally it was positive, but we classified it is negative. That is misclassified. So again misclassified negative, that is originally it was positive, but W plus X update is W equal to W plus X, W equal to W plus X, and W plus X, and W transpose X is less than 0. Originally the given X2 data point is positive, but we calculate the W transpose X, which is less than 0, that is minus 1.5, which is less than 0. So the update is W equal to W plus X. So W2, new W, right? W2 equal to W1 plus X is here X2. Here X2. So X2, that equal to W2 equal to W1 is 0, 1.5 plus X2 is 1 minus 1. So that is new W equals to new W is equal 1, that is 0.5. Again we find the W2 transpose X2, that equal to 1, 0.5. Here the W is updated second time. W2 updated, second update. 2 means X2 equal to 1 minus 1. So that equals to 1 minus 1.5, that equal to 0.5, which is positive. 0.5, which is positive, that is P classified correctly. So two updates are, how many data points are correctly classified, they are asking. This is also misclassified. This is also misclassified. Here W is updated to W1. Here the W is updated to W2. Next data point X3. Dot product W2 transpose X3 data point. W2 is, so this one 1.5 with X3 equals to minus 1 comma 1. So the dot product is, you have to multiply this one, so minus 1 plus 0.5. This is also negative, minus 0.5. This is that means W2 transpose X3 is less than 0, that is negative. But given originally the data point X3 is positive, W equal to W plus X, update X3. Originally if W transpose X3 is less than 0, originally the data point X3 is positive, X3 is positive, we find the W2 transpose X3, which is less than 0. So update the W2 3 equals to W2 plus X3. So W3 equals to, again the third update of W3 equal to W2 plus X3. W plus X, what is the rule? You have to update the weight vector W equal to W plus X. When we update the weight vector, when W transpose X is less than 0, the data point is less than 0, when you can update, that is W2 equals to 1 and 0.5 plus X3 is minus 1 and 1, here X3. So updated weight vector W3 equals to minus 1 plus 1 0 and 1.5. Now we again find W3 transpose X3. W3 equals to this value remember third update, because it is misclassified. Third update, this is third update, this is the second update. So W3 transpose X3, so 0 1.5 to X3 is minus 1 1, the dot product is 1.5, that is W3 transpose X3 greater than or equal to 0, that y hat equals to 1, is positively classified. After updated weight vector, it is positively classified. Before it was misclassified, so this is also misclassified. The weight vector is updated, W3, and the last data point minus 1, it originally it was negative. Find this value. So again W3 transpose X4, last data point. So W3 transpose X3 equals to, so 0 comma 1.5, X4 is minus 1, so we have to find 0 minus 1.5, which is less than 0, that is W3 transpose X4 is less than 0, that is negatively classified. Originally also it was negative, so there is no misclassification, no weight vector update. No weight vector is updated. So for this question, how many data points are correctly classified? For this question, how many data points are correctly? Only one, X4 is correctly classified. For this question, answer is X4 is only correctly classified. This one answer. See, how to find means, first check the original data points is positive or negative. Given, you have to remember this table, very important. Original means given in the question. If it is originally positive or negative, in the question x1, x2, x3 are positively classified, x4 is negatively classified. And find the W transpose X. If it is the data point is x1, you find W transpose x1. If you find the W transpose x2, x3, x4, like that. If it is less than 0, for positive it is less than 0, that is misclassified, right? For negative it is greater than 0, misclassified. If it is misclassified, you have to update weight vector W. You have to update the weight vector. If it is negative, minus. If it is positive, plus. So add new W equals to W minus X. New W equals to W plus X. This one new value. This one new W. If it is x1, W1 plus x1, W1 minus x1. Okay, remember this table. If it is positive, less than 0, if we find the next step is find W transpose X. If it is less than 0, for positive it is greater than 0. So in perceptron, y hat equals to 1 when W transpose X greater than or equal to 0, or 0 for W transpose X is less than 0. So positively classified. If it is less than 0, it is misclassified. So further W plus X. So for this question, the correct answer is only X4. Only one is correctly classified, that is X4. Next question. So update the weight vector value using the perceptron learning algorithm by visiting the following points in order: X4 and X3. What is an angle in degrees between the updated weight vector and the initial weight vector? Okay, there is no space. Vector values using the perceptron algorithm by visiting the following points in order. So they give in order x4, x3. This is the order. What is the angle in degrees between the updated weight vector and the initial weight vector? That is W0 and updated weight vector. We don't know how much it is updated. The given W equal to, we find the W, right? -1, 0.5. Initial weight vector is given in the question. So in this problem, so W0 is given -1. So we find W equals to W0. This is the initial weight vector value, -1, 0.5. So in this question, W0 initial weight vector -1.5 and x4. So W0 and x4 equals to -1, -1. So find the W0 transpose x4. That is, we are predicting the given data point. -1.5 to -1, -1. We be careful at this point. That equal -1 into -1 plus -1 into 0.5. That equals to -1 into -1, 1 minus 0.5. That equals to 0.5. So originally the data point x4 is negative, but we find the W0 transpose x4, which is greater than 0. That is 0.5 is greater than 0. So misclassified. So update the weight vector. So W1 new weight vector equal to W0 minus x4. That equal to W0 equals to -1.5 minus x4 equals -1. That equals to -1 plus 1, 0.5 plus 1. So W1 equals to new update. W1 equals to 0, 1.5. New weight vector, this one. And again we find W1 transpose x4. That equals to 0, 1.5 into -1, -1, -1.5, negatively classified, correct, no update. Next, the data point x3. So W1 transpose x3 dot product. W1 equals to 0, 1.5, and given x3 equals to -1, 1. So the dot product 0, 1.5. That is positive. So given originally x3 is positive, we find the W1 transpose x3 equal to 1.5, which is greater than or equal to 0. That is y hat equal to 1, correctly classified, and there is no update. So they given only 2 data points in the order. They given only 2 data points. We find final weight vector W1 value equals to 0 and 1.5, and initial weight vector W0 equals to -1 and 0.5, and updated weight vector. Find the angle. They are asking angle. So cos theta equals to W1 dot product W0 dot product W1 divided by W0 W1, that equals to 0, 1.5 minus 1 0.5 square root of 1.5 whole square, square root of 0.5 whole square plus 1 square, so that equals to 0 into minus 1 0. So 1.5 into 0.5 divided by 1.5 square root, this one cancel, into 0.5 whole square. So using calculator, zero point 0.5 power power 2, 0.25 plus 1 plus 1, 1.25 square root of 1.25 equal to 1.118. So 1.5 1.5 cancel, that equal to cos theta equal to 0.5 divided by 1.118. 0.5 divided by 1.118 equals to 0.44. So theta equal to cos inverse of 0.44. Cos inverse is not there. 63.89 in degrees. This is the answer. So theta equals to 63.89 degrees. So answer is in this range, correct. 63.89 in this range, 62.5 to 64. Okay. Friends, if you like this question, please like and subscribe my channel.